In this video, we will discuss about smart robots, how robots can use PSO to find out the optimal solutions. So we will try to understand this using an example, robot searching for the charging station. So imagine we have a group of robots in a warehouse and these robots need to find the best charging station before their batteries run out. Here the best charging station is the optimal solution that the robots are trying to find out. Here, we will use PSO algorithm to find out this optimal solution, that is the best charging station. So here you can see we have a large warehouse with multiple charging station placed at different locations, and we have a group of robots moving around the warehouse, and each robot has a battery level, and the goal is to find out the nearest and most efficient charging station before their batteries run out. So we have different types of charging station with features like quick charger, standard charger, and superchargers. So here, based on their needs, robots will prioritize different stations. So now we'll try to understand how robots might choose the different station depending on factors like charge time or energy efficiency. Here, as we have the robot with different battery levels, so the robots with lower battery levels might prioritize the nearest charging station, while the robot with higher battery level can afford to search longer. So we have a dynamic environment here. So charging station may be available or not available over time due to maintenance or uses. So how robot will adapt to these changes? This reflects the dynamic nature of real world problems. Now robot has to adapt to these changes. If the charging station is available or not available, according to that they have to move, and if the battery is lower or higher, so they have to change their search strategy. Next factor we are adding here, suppose we have competition also here. So we have competitive elements where robots are racing to find the best charging station like we human do. So here robots are also racing, they are competing with each other to find the best charging station. Here suppose they could be competing for the limited resources. So done, we have a scenario here, robots in a warehouse that need to find out the best charging station, and we are using a PSO to help the robot to locate the optimal charging station. Robots movement in the warehouse, that is the exploration. They are exploring the warehouse for the best charging station. Robots start moving around the warehouse, and each robot with different starting point. A different starting point means they have different initial position, and each robot keeps track of best charging station it has found so far, that is personal best, and communicates with other robots to learn about the best station found by the other in the group, that is the global best. So as in the PSO algorithm, you can see in the velocity update formula, we have P West and G West. P West, that is the personal best, G West here is the global best. So when we will update the velocity for the robot, here robot speed and direction change is done based on two factors. First, the best charging station the robot has found so far, that is the personal best. Second, the best charging station any robot in the group has found, that is the global best. You can see V new, that is the new velocity, V old current velocity, C1, C2, then the constant, R1, R2, we have the random values, X is the position. Here, robot will continue explore, they gradually start converging toward the best charging station in the warehouse. The robot that find the better solution update their position and share this information with the group. So the robot's movement slow down as they get closer to the best charging station, optimizing their search based on personal and the group knowledge, personal best and the global best. So eventually, in the end, all the robots will converge on the best charging station. As we know how PSO algorithm work, this algorithm will repeat until maximum iteration. Suppose we have 1000 iteration. In each iteration, we will find out one best solution, that is the near optimal solution. So after 100 iteration, it will give us the optimal solution. All the robots will converge on the best charging station where they can charge effectively. So we are using here PSO algorithm to help the robot to find optimal solution by balancing exploration, that is checking out new charging station, and exploiting moving toward the best known stations. Done. So robot move around the warehouse tracking their best found charging station, that is the personal best. Done. And sharing information with other robots, with other, that is the global best. So we will update the velocity using this formula. After that we will start the convergence process. Robot gradually converge on the best charging station, optimizing their search based on the collective knowledge. So here PSO balance the exploration of the new option and exploitation of the known good solution. Each robot might have different requirement for charging depending on its battery level. So robots might need quick charge while other might prioritize longer charge. So we have variable optimizations. So instead of one single optimal charging station, there could be different charging station that are optimal based on specific need of each robot. Done. So we have multiple charging station. Different station can offer various charging speed or capacities like quick charger, standard charger, and supercharger. So the robot have different battery levels, therefore different needs for charging. So this problem can be considered as a multi-objective optimization problem because this involves optimizing more than one objective function simultaneously, which may be conflicting or competing. So in this case, the objectives are various charging needs of the robots. So we have here multiple objective. So first objective, we have to find out the charging station that offer the fastest recharge time for robots with low batteries. Second objective, identify station that provide long lasting charges for robots with high battery levels. Third objective, optimize the best trade-off between charging time and charging capacity for each robot. So each robot will prioritize charging station based on its specific need. The concept of Pareto optimality can be applied here, where no robot can be made better off without making another robot worse off. This means finding a balance where the overall system needs are met efficiently. So each robot has different battery level which lead to multi objectives for finding the best charging station. Some robot need quick charge, other need long lasting charges and other. So algorithms that we can use for multi-objective optimization problem, we can use here NSGA2, that is non-dominated sorting genetic algorithm, or we can use here MOPSO, that is the multi-objective particle swarm optimization to handle multiple objective and find Pareto optimal solution. So in multi-objective optimization problem for robot with varying battery levels, each robot seek for the best charging station based on its specific need. So by balancing the criteria such as charging speed and capacity, PSO algorithm can help to find optimal solution that match each robot requirement. So here we try to optimize a real world optimization problem where we have a group of robot and they are moving in a warehouse and they are searching for the optimal charging station based on their requirement. So this problem can be a little bit complicated here. We can define the objective function clearly, then apply the respective algorithm to find out the best solution. So PSO is used here to simulate how these robots find the best charging station. PSO involve a group of solution, that is the robot exploring the problem space, that is the warehouse, and sharing information to converge on the optimal solution. So each robot start at different location in the warehouse and begin searching for the best charging station. And they keep track of the best charging station they found so far, that is personal best, and communicate with other robot to learn about the best station found by the group, that is the global best. So robots begin in cluster around the best charging station. Initially they are scattered, but over time their movement become more focused on the optimal solution. So BSO help the robot to optimize their search. The robot adjust their search direction based on their own discoveries and collective knowledge of group, leading them to converge on the best charging station This process illustrates how the PSO balance exploring the new areas and exploiting the known good solution. Here PSO is balancing both exploration and exploitation. The robots exploring the new areas and exploiting the known good solutions. So robots might prioritize charging station based on their specific need. Robot with low battery might prioritize nearest station, and other might look for the station that offer faster charging. And we have the dynamic environment that simulate the scenario changing station becoming charging stations are available, not available, done. So this reflects the real-time situation where conditions change dynamically. So here robots need to continuously adapt to their strategies to account for these changes. Here you can see iteration and the fitness values. In each iteration we obtain a different best fitness value that will repeat until maximum iteration. And here you can see the robot's position in the search space, that is the warehouse. And here you can see in each iteration we have the different fitness values. Here each robot start at random position with initial velocity. Goal is to find the best charging station. So we will update the velocity for each robot using velocity formula, how the velocity vector changes based on the personal best and the global best. Then initially we have robot at random position and you can see the initial velocity vectors. Then in intermediate frames we will update the velocity, robots moving based on new velocities. In the final stage, robots will cluster around the best charging station and velocity reduce as the robots converge on the optimal solution. Exploring the search space, then robots moving closer to the charging station and then converging, then robots clustered around the charging station. So that's all about this video. If you have any questions, you can comment below, and thanks for watching this video.